Ta-da! When we do matrix multiplication, this means we're actually going to take a matrix and multiply it by another matrix. This is a little bit more complicated because you have to multiply the row from the first matrix with the column from the second matrix. So dimensions really, really matter. So take a look at these examples that I put up here. The first dimensions are a 2 by 2 matrix. I want to take a 2 by 2 matrix multiplied by a 2 by 1 matrix. And you'll notice that's what we have down here. This is a 2 by 2, and we're multiplying by a 2 by 1. The important thing is that the two middle dimensions must match perfectly. When the middle dimensions match, you can do the matrix multiplication, and the end result will be the dimensions that are left on the outside. So a 2 by 1 matrix will be the result. If we have a 2 by 3 times a 3 by 1, notice these middle numbers match, and then 2 by 1 ends up being the final dimensions. 3 by 2, 2 by 1, it's going to end up becoming a 3 by 1. So if you want to kind of draw this underneath, 2 by 2 times 2 by 1. The 2's in the middle match. Someone in third hour said, so it's kind of like those go away. They kind of like drop out. And a 2 by 1 is your resulting matrix. So our end matrix, our answer is going to be a 2 by 1. Okay, so I am going to draw 2 rows, 1 column. We're going to put numbers in those 2 boxes. I think I might redo that in black, just because. Okay. Here's how this works. I will use colors to help guide you. First, purple. We need to multiply the first row times the first column. So we are going to do 2 times -1. So take a moment and see where that 2 times -1 came from. It's the first term in the first row multiplied by the first term in the column. We're going to add to that the 3 times the 7. So we move left to right in the first matrix. We move up to down in the second matrix. 2 times -1. I need to set my computer down so I can show this. 2 times -1 plus 3 times 7. So you're moving like this as you're multiplying. 2 times -1 is -2. 3 times 7 is 21. What is -2 plus 21? 19. That's the number that goes in the first row, first column of our answer.
21.
Now let's do the second term. We need to multiply the second row with the only column that exists. So we are going to do 4 times -1 plus 5 times 7. 4 times -1 plus 5 times 7. I wish you could see my fingers as they move. This is -4 plus 35, which is 31. So that is the second part of our answer matrix. Our answer matrix is 2 rows, 1 column, 19, 31. Do you want to see another one of these?
No. Oh my God. All right, let's do the whole one.
Wow.
Sorry.
If we want to do another one, I'm going to let you pause the video and try this on your own, and then I'll put the answer up. Let's do 2, 1, 5, 3. I'm just making one up. Okay, this is a 2 by 2 multiplied by a 2 by 1. The middle numbers match. Our resulting matrix is going to be 2 by 1. So, highlighter, you're going to have a term right here, and you are going to have a term right here. Pause the video, try that one on your own. Okay, we would do 2 times -2 plus 1 times 4. I honestly just put that in my calculator. Let's see, that's -4 plus 4, which is 0. Then we would do, sorry if this looks different, my thing died and whatever. 5 times -2 plus 3 times 4, which would be -10 plus 12, which is 2. So your answer matrix would be 2 rows, 1 column, 0, 2. Next slide. The determinant. Okay, here's the frustrating thing. There's a lot of applications for the determinant. None that we're actually going to do, but there's a chance that in the future you'll see matrices, you'll see something, and they'll ask you to find the determinant. I want you to at least have experienced it. The determinant has applications like finding areas of figures. You can actually use determinants with matrices to find solutions for systems of equations. There's a whole bunch of things that you can do with it. And the determinant is actually ridiculously easy. You start by multiplying diagonally. A1 times B2, then you multiply diagonally the other way. A2 times B1, that term is written there, and then you subtract those two terms. So in this first example, what is 2 times 4? 8. What is 1 times -3? -3. I don't care if it's positive or negative, you are going to subtract those two terms. So 2 times 4 minus 1 times -3. You can honestly, once you get good at this, just type it into your calculator exactly like that. 8 minus a -3 is 11. So the determinant of matrix A is 11. For B, we would do -1 times -4 minus 2 times 2. 4 minus 4 is 0. The determinant of matrix B is 0. If you know the formula for determinants, this is like crazy easy. Diagonal multiply, subtract them, and you're done. Your assignment